In this lecture, we will go ahead and take question number 13 to 15 of ISI PEA 2004 paper. Look into the question better. This says you are given u is equal to sine inverse x square plus y square upon x plus y. And you need to calculate x del u by del x plus y del u by del x. First of all, there is a printing error in this question. It should x del u by del x plus y del u by del y, not del u by del x, right? This needs to be corrected. This will be del u by del y. Okay. Now just try to see how we have to solve this question. So what you can do is you can start by taking u is equal to sine inverse x square plus y square upon x plus y. And here we need to use the property of homogeneous functions. So if I have any function which is homogeneous of degree r, then we can go ahead and we can write that function like this. So if I have a function f of xy which is homogeneous of degree r, then I can go ahead and write this function as x differentiation with respect to x plus y differentiation of f with respect to y is equal to the function multiplied with the degree of homogeneity. So in this case, but what is going to happen therefore is that I have this u is equal to sine inverse x square plus y square upon x plus y. So what I can do is I can just take this sine inverse here and I will be getting sine u is equal to, so just try to understand. I am taking the sine inverse on this side. So I will be getting sine u is equal to x square plus y square upon x plus y. Sine u is equal to x square plus y square upon x plus y. Now look into this. Suppose I call this function as sum w. So I will be getting w is equal to x square plus y square upon x plus y, right? Now try to see the degree of homogeneity of this function w. So if instead of x, I will write lambda x whole square. Instead of y, I will write lambda y whole square upon instead of x, lambda x, instead of y, lambda y. So here I will be getting lambda square x square plus lambda square y square upon lambda x plus lambda y. And if I just go ahead and I take lambda square common, I will be getting x square plus y square upon, I'll take lambda common and I will get x plus y. And this will go ahead and give me lambda x square plus y square upon x plus y. So this will go ahead and give me lambda into the function. So the power of lambda is 1. So the degree of homogeneity that we are talking about is 1. So we can say that this function w, this has the degree of homogeneity which is going to be 1. Now I'm going to go ahead and I'm going to use this property again, the same property that I have used here, right? So which function am I talking about? I am talking about the function w. So I can say x del w by del x plus y del w by del y is equal to r into w. And I know that here my r is 1 because the degree of homogeneity is 1. So from here, what we can go ahead and get therefore will be this function, this equation. And what is the equation? X del w by del x plus y del w by del y is equal to 1 into w. Now what I can go ahead and do is I need to write this function in terms of u again. And if you remember, I had nothing, but I had w is equal to sine u. W was nothing but sine u, which was nothing but x square plus y square upon x plus y. So I can just replace this w back with sine u. And what I can do is that because w is sine u, and if I have to go ahead and I have to use the chain rule, then I understand that if I have to differentiate w with respect to x, then it is like differentiating this function with respect to u and u with respect to x, right? So this is what I have done here, that in order to differentiate w with respect to x, actually I can go ahead and I can say that w is differentiated with respect to u. and u is differentiated with respect to x. Similarly, I can say w is differentiated with respect to u and u is differentiated with respect to y. And here instead of w, what I have gone ahead and I have done is I have written sine u here. Now what I can do is I can just go ahead and from this entire equation, I can take del w by del u out and common. So when I will be taking del w by del u common, inside I will be getting x del u by del x plus y del u by del y is equal to sine u, is equal to sine u. Now try to understand this thing better. So if you remember, you know that w was written as sine u. So if I were to find this out, what will be del w by del u? If I have to differentiate this with respect to sine u, I will get the answer as cos u. So here I will be getting this part as cos u into x del u by del x plus y del u by del y is equal to sine u. And then I can just take this on the other side and I will be getting this as sine u by cos u, which will be nothing but tan u. So I will be getting x del u by del x plus y del u by del y as nothing but tan u. And this is exactly what was asked to us in the question. So we had to find the value of x del u by del x plus y del u by del y. So the correct answer to this question will be tan u. Okay, beta, come to the next question. This is pretty simple. This is just asking us to find the derivative of tan inverse cos x plus upon 1 plus sin x. So actually you just have to use the very simple property of differentiation. एक एक करके differentiate करेंगे. So I need to find out dy by dx, y with respect to x. So dy by dx will be, first of all, I will find the differentiation of tan inverse. So whenever you have to go ahead and do the differentiation of tan inverse x, then dy by dx is given by 1 upon 1 plus cos 1 upon 1 plus x square. 1 upon 1 plus x square. Now here my angle x itself is this, cos x upon 1 plus sin x. So if I were to go ahead and differentiate this, so instead of x, I will write my angle and my angle will be cos x upon 1 plus sin x whole square. Cos x upon 1 plus sin x whole square. So this is the first part where I have gone ahead and I have differentiated tan inverse. Right? Now into, I must differentiate the angle itself. Right? There must be differentiation of the angle itself. And we need to see that here my angle, the angle that I have here, the theta that I have here, that is actually cos x upon 1 plus sin x. So if I just differentiate this angle now, so differentiating the angle would go ahead and would mean that I need to use the quotient rule, right? So differentiation of the numerator, the differentiation of cos x will be minus sin x into denominator as it is minus differentiation of denominator. So differentiation of 1 plus sin x would be cos x. Differentiation of 1 will be 0, sin x will be cos x into the numerator as it is upon the denominator square, upon the denominator whole square. So this is what I have gone ahead and I have done here. So if you can notice here, beta, this is differentiation of numerator into denominator as it is minus differentiation of denominator, numerator as it is upon denominator whole square. Now this is very simple. I just have to go ahead and simplify this. So if you just look into this part again, so this will go here and then this will go into the numerator, right? I will just take you through this a bit more. So I'm just looking into this part. So this is 1 upon 1 plus cos square x upon 1 plus sin x whole square. So this will go here. So this will be 1 upon 1 plus sin x whole square plus cos square x upon 1 plus sin x whole square. And then this will come here, beta. So this is going to be equal to 1 plus sin x whole square upon 1 plus sin x whole square plus cos square x. So if you notice here, this is what is written here. And then you can just open up the denominator. So if you just look here, this will be 1 plus sin x whole square upon denominator will be a square plus b square plus 2ab plus, I am just keeping this as it is, plus cos square x. So this will be 1 plus sine x whole square. And if you notice, sine square x plus cos square x, this is going to be 1 beta, right? So sine square x plus cos square x is 1 plus 1, that is 2. So 2 plus 2 sine x. So this is going to be 1 plus sine x whole square upon, I'll take 2 common, 1 plus sine x, and this will cancel out. So this will be 1 plus sine x by 2. 1 plus sine x by 2. So we have seen that at least the left hand side, that means this part, it just goes ahead and it becomes what I just mentioned to you here, which means 1 plus sine x by 2, right? Now we need to look into the right part, right? We need to look into this part now, beta. So now if I just go ahead and I look into this part, so what will I get here? So minus sine x minus sine square x minus cos square x upon 1 plus sine x whole square, right? So I can do this as minus sine x minus, and if I just take minus common, this will be sine square x plus cos square x upon 1 plus sine x whole square, right beta? So this is going to be minus sine x minus, and sine square x plus cos square x will be 1 upon 1 plus sine x whole square. And if I just take minus 1 out, so this will be 1 plus sine x upon 1 plus sine x whole square. And then this will cancel out and it will be minus 1 upon 1 plus sine x. So this side, this part entirely when solved, it gives minus 1 upon 1 plus sine x. And that part, when that was being solved beta, it was giving us this. Now the two are being multiplied together. So I have 1 plus sine x by 2 into minus 1 upon 1 plus sine x. And this will cancel out and it will give me the answer as minus half. So if you just notice, I have just done that simplification here. ऐसा कुछ भी नहीं है. This is simple chain rule. पहले tan inverse का chain rule लगाया. So we solved for tan inverse. Tan inverse का differentiation will be 1 upon 1 plus x square, where x is the angle. The angle here is this thing. So I have written the angle here. Into, you always differentiate the angle itself. So here to differentiate the angle, I used the quotient rule. And then I just tried to simplify that up. And when I simplified it, I got the answer as minus half. I got the answer as minus half. Okay, look at the next question now. So this says the sum of the infinite series is, so the series that is given to you is this. And whenever you find such series beta, the simplest way to solve such series is to look whether this series actually belongs to the APGP series that we have studied. So if you notice, yes, this is in fact an APGP series. What is an APGP series? If you look into the numerator always has a common difference. So, if you see this, the first is going as 3 minus 1, which is 2. Then it is 7 minus 3, which is 4. Then it is 15 minus 7, which is 8, right? So this is how the series is progressing. And in the denominator, if you see, the denominator is also going ahead and becoming 4, 16, 80, 64, and so on. So the denominator, so if you notice, I can go ahead and I can say that if I look into the second term is 1 plus 2 times the first term. 3 is nothing but 1 plus 2. And the third term is nothing but 1 plus 2 times the second term, right? Right? So I can go ahead and say that an will be 1 plus 2 an minus 1, right? I can go ahead and I can say that an is nothing but 1 plus 2 an minus 1. The last term, whatever last term you have, just look into the numerator, huh? Whatever last term, what 7 can be written as 1 plus 2 times 3, right? Similarly, 15 can be written as 1 plus 2 times 7, right? So an can be written as 1 plus 2 times an minus 1. And if you look into the denominator is 4 to the power n, where n starts from 0. So this is nothing but 4 to the power 0, 4 to the power 1, 4 to the power 2, and so on and so forth. So kind of an APGP series has been created, and therefore what we need to do is we need to go ahead and look into the denominators particularly, right? Where we see the GP, and let S represent 1 plus 3 by 4 plus 15 by 64 and so on. And what I will do is I will rewrite this thing as 4 to the power 0, 4 to the power 1, 4 to the power 2, then 4 to the power, I missed out something, right? I missed out a term here. So this is plus 7 upon 4 to the power 2, 4 to the power 3, 4 to the power 4, and so on, right? Now what you will do is you need to go ahead and you need to find out such a way that your S gets multiplied with the GP term. And the GP term here is 1 by 4. If you notice, right? If you notice the common term, every term is getting multiplied with 1 by 4 if you look into the denominator. So what I will be doing here is I will be multiplying S throughout by 1 by 4. And this will give me, so, when I will multiply 1 by 4 to the power 0, which means 1 into 1 by 4, I will get the answer as 1 by 4. But I will be writing that 1 by 4 here. Then when I will be multiplying 3 by 4 with 1 by 4, I will be getting 3 by 16. But I will be putting that here. Then when I will be multiplying this by 1 by 4, I will be getting 7 by 4 to the power 3, 64. But I will be putting it here and so on. Are you getting it? So once this series is multiplied with 1 by 4 throughout, what we will be doing is, because the two are infinite series. Ye infinite series hai. It does not has any end. So even if I multiply it with 1 by 4, it will remain as an infinite series. So what I will be going ahead and doing is I will be multiplying it with 1 by 4, but I will be going ahead and putting it with one step down, right? I will be keeping this aside. Isko nahi chuna hai. Once you multiply this with 1 by 4, you will be putting it here, corresponding to these terms. Am I clear with it? So when 1 is multiplied with 1 by 4, that becomes here, it comes here. This comes here, this comes here, and so on and so forth. And both will be infinite series, so it does not create that difference. And then you will be going ahead and doing S minus 1 by 4S, and this will be 1 plus 2 by 4 plus 4 by 4 square plus 8 by 4 cube, and so on. Am I clear with it? So on the left hand side, you clearly can see that this is 3 by 4S. And now if you look into the right hand side, now you will be able to make this up that this is nothing but this is 1 plus half plus 1 by 4 plus, so this is 4 into 4 into 4, right? So this part is 8 upon 4 into 4 into 4. Am I clear with it? So beta, this is nothing but 1, 2, 2. So this is nothing but 1 by 8. So this will give you plus 1 by 8 plus 1 by 16 and so on. So what you will see now that from the APGP series, I have been able to go ahead and create a GP series. So now I can just rewrite this thing as 1 by 2 to the power 0 plus 2 to the power 1 plus 2 to the power 2 plus 2 to the power 3 and so on. And this is an infinite GP. So its sum will be A upon 1 minus R. A is the first term. Upon 1 minus, the common ratio is half. So 1 upon half. So this will be 2. So I will be getting that 3 by 4S. So I will be getting 3 by 4S is 2. So S will be 2 into 4 by 3. So this will be 8 by 3. So the sum of this infinite series will be 8 by 3. And that will be the answer to this question. Am I clear with it? Okay, beta. Thank you.